I welcome you all. This is Jagadeesan, Assistant Professor, Department of Computer Science and Engineering in RMD Engineering College. So, representation of the graph. In this video, we can learn about the representation of graph. A graph representation is taking store the graph into the memory of the computer. To represent a graph, we just need to set up the vertex. For each vertex, we neighbor of the vertex. The vertex which is directly connected to it by the edge. If it is a weighted graph, the weighted will be associated with the each edge. There is a different way of optimally is represent a graph depending on the density of the edges, the type of operation to be performed, and easy of use. So adjacency matrix, the adjacency matrix is a sequence representation. It is used to represent which node is adjacent to the each other. That is the any edge connecting to the nodes to the graph. So in this representation, we have to construct extend the matrix of A. So if there is any edge from the vertex I to the vertex J, the corresponding content of A of ij equal to 1, otherwise A of ij equal to 0. If there is any weighted graph, then it's instead of ones and zeros, we can show the weight of the edges. Undirected graph. Is here the A to B is there. So link A to B 1 and A to C 1, A to D is 1. We can take one vertex, we have to, a path is there, we are putting a 1 here. Then directed graph is a direction based on the direction we have to A to B direction is that one. A to C direction is that one. A to D there is no direction. A to E also there is no direction. We have to assign the zero. Undirected weighted graph. In that weight will be there. So A to B, what is the weight? 7. Then A to C, what is the weight? 8. A to D, what is the weight? 5. A to E, there is no connectivity. So in that undirected weighted graph, we have to assign the weight here. Then directed weighted graph. So here direction will be there based on the we take this 1 to 3 is the connection. The weight is 3. Then 1 to 4, 3 is a weight. The other things are 0. Like a way we have to draw the table. Adjacency list. The adjacency list is linked list representation. In this representation, for each vertex in the graph, we maintain the list of the neighbor. It means every vertex of the graph contains the list of the adjacency vertex. We have the array of vertex which is indexed by the vertex number, and for each vertex we corresponding array element point to the singly linked list of the neighbor of the V. So that in the graph we see A to B. So link is there. Then B to C, link is there. Like a way, the A, the communicate to B as well as C. The any more communication is not there. So direction not there. So that we can stop there. In B, we take it as a B. B to D is there. B to E is there. There is no connection. So that we can draw the link list. So weighted linked list, adjacency list representation. The adjacency list, each element in the list, we have the two values. The first one is the destination node. Second node is the weighted between those two nodes. The representation like below. 1, 2, 3, 4. How many nodes is there? After that, 1, 1, 2, where 3 is there. Connectivity is there. Weight is 6. 1 to 4. Connectivity is there. 3. There is no connection. Like a way 2. 2 to 1 is there, connection is there. There is no connection, the weight is 3. Like every we have to assign here. Thank you.